Sketching the graphs of functions, part 4. For the function f of r maps to r, f of x is equal to minus x cubed over 3 plus 4x minus 1. Part 1, find the stationary points and determine their nature. Part 2, sketch the graph. So we write out the function. Stationary points are when the derivative is equal to 0. So the derivative is from calculus, so we may not have covered calculus yet, but it links in very closely with functions. So the derivative is going to be minus 3 times x squared over 3 plus 4. So what we do is we bring the power down, so the 3 comes down in front, and then we reduce the power by 1. And then with the 4x, we just cross off the x, and the minus 1 is a constant, so that would become 0, so we don't write anything down for minus 1. Then to simplify, well, the 3's will cancel, so we end up with minus x squared, and we still have plus 4. So that's our derivative. So then we let the derivative equal to 0, and now we solve for x. So x squared is equal to 4. So letters to the left, numbers to the right. So x is equal to the square root of 4. So x is equal to plus or minus 2. Because 2 squared is 4 and minus 2 squared is also 4. So you actually get two solutions. So plus or minus 2. So now we're going to find the second derivative and sub in 2. And find the second derivative and sub in minus 2. So from the previous slide, we worked out that x is equal to plus or minus 2. So the function was minus x cubed over 3 plus 4x minus 4. The first derivative was minus x squared plus 4. And now the second derivative, so we basically just differentiate the first derivative. So we bring the power down in front, so the 2 comes down in front of the x, and we reduce the power by 1, and 2 minus 1 is 1. So technically it's x to the power 1, so we just write x. So we end up getting minus 2x when we differentiate minus x squared. And then the 4 is a constant, so the derivative of that would just be 0. So we don't need to write down plus 0. So the second derivative of our function is minus 2x. So then we get, we sub in 2 into the second derivative. So we have minus 2 times 2 is minus 4. Which is negative. Therefore, the maximum turning point is at x is equal to 2. And then we sub in minus 2, because remember at the top here we got x is equal to plus or minus 2. So we sub in minus 2 into the second derivative. So we have minus 2 times minus 2, which is positive 4. So that's positive. Therefore, we have a minimum turning point at x is equal to minus 2. So when you sub into the second derivative, if you get a negative, you've figured out the maximum turning point. And if you get a positive, you figured out the minimum turning point. So again, we worked out x is equal to plus or minus 2. That was in the previous slide. So at x is equal to 2, f of 2 is going to be minus 2 cubed over 3 plus 4 times 2 minus 1. So we're subbing 2 into the original function now. We're not subbing into the derivative or the second derivative. We're subbing into the original function. So we sub in x is equal to 2. And that gives us 4 and a third. Therefore, the minimum turning point is at 2, 4 and a third. So again, we worked out x is equal to plus or minus 2. So now we take the minus 2 and we sub it into the original function. So we're going to work out f of minus 2. So we're replacing both of those x's with minus 2. That should be a minus there. And we end up getting minus 6 and a third. Therefore, max turning point at minus 2, minus 6 and a third. So we've worked out the minimum turning point, 2, 4 and a third, and we've worked out the maximum turning point. Minus 2, minus 6 and a third. So part 2 asks us to sketch the graph. So we found the stationary points and we determined their nature, maximum and minimum turning points. So we go back to our original function, f of x equals minus x cubed over 3 plus 4x minus 1, given in the question. We're going to let x equal to 0, so we work out f of 0, so replacing both of those x's with 0, and we get minus 1. Therefore, our curve crosses the y-axis at 0, minus 1. So the x value is 0, the y value is minus 1, so putting them together we get 0, minus 1. We get the second derivative, so we worked that out, we don't need to do it again. The second derivative was minus 2x, we got that from the previous slide. So we're going to let the second derivative equal to 0 to find the point of inflection. So we replace the second derivative with 0, so we have 0 equals minus 2x. And solving for x, we get x is equal to 0. Therefore, the point 0, minus 1 is the point of inflection. So the point of inflection just so happens to be the point where the curve crosses the y-axis, but this will not always be the case. It's just a coincidence. So there was no need to sub in x equals 0 to find the y value because we already had it from up here. Because we'd already subbed in x is equal to 0 to give us minus 1. So that's where that minus 1 came from. So to summarize, we have minus x cubed over 3. Therefore, we have this shape. So it's like an S on its side. So it's going downwards, then it turns and goes upwards, then it turns and goes downwards again. The max turning point, the maximum turning point is 2, 4 1/3. The minimum turning point is minus 2, minus 6 1/3. It crosses the y-axis at 0, minus 1, and this is also the point of inflection. So to draw it out, we have our important points. So we have 0, minus 1. So that's 0, minus 1 there in red. We have minus 2, minus 6 1/3. So minus 2, minus 6 1/3. And 2, 4 1/3. So 2, 4 1/3. So we draw them in the green curve as accurately as we can, making sure that it's an S shape, making sure that it is curved at the maximum point and not pointed. And again, that it's curved at the minimum point, the minimum turning point, and it's not a point. So it's not a zigzag, it's like an S shape. Now you can use the table function on your calculator to generate more points to make it accurate, but it's important that you know how to generate these points without using the calculator.